Acid-Base Balance by Kimberly Jarrett. The basics. What is pH? It measures how acidic or basic a substance is. The pH scale ranges from 0 to 14. pH measures the concentration of hydrogen ions. Normal pH is 7.35 to 7.45. So the lower you are, if you're under 7.35, we consider you acidic. And then if you're above 7.45, you're more basic or alkalotic. What is an acid? An acid is a hydrogen donor. Strong acids dissociate completely, whereas weak acids do not. What is a base? A base is a hydrogen acceptor. You can also classify them as strong or weak, just like you can with acids. How is acid-base balance regulated? It's regulated through buffer systems, respiration regulation, and renal regulation. I really like this picture. It just shows the different steps, the buffer system, respiratory, and renal. If you have too many hydrogen ions, you will be more acidic. The body works with a very narrow range. Small pH changes alter biologic processes. Most diseases can cause an imbalance. An imbalance can cause more problems than the disease itself. And then this just shows the different steps if you want to go ahead and read that. Very, very helpful slide. Buffer systems. Buffers act like bases by preventing changes in pH by binding hydrogen. Buffers convert a strong acid or base to a weak acid or base. The reaction occurs within seconds. There are three types of buffer systems. There's a bicarbonate buffer system, a phosphate buffer system, and a protein amino acid buffer system. Respiratory regulation. This increases or decreases the amount of carbon dioxide expelled from the lungs depending on what the body needs. The reaction occurs within minutes. It's effective after about 6 to 12 hours. And hypoventilation is an increase of carbon dioxide, pushing this equation above to the right, and the increase of hydrogen concentration. Hyperventilation is just the opposite, and so this equation that's right above me here will reverse the equation to the left because there's a decrease in carbon dioxide. Renal regulation. It removes hydrogen or adds bicarbonate in the body. It takes hours or days for this reaction to occur, so it's the slowest one, but it is very effective. It just takes time. It regulates hydrogen levels and bicarb levels, and it synthesizes bicarb. Arterial blood gases. This tests the adequacy of oxygenation, PO2, ventilation, pH and PCO2, and acid-base balance, which is pH, PCO2, and HCO3 bicarb. PCO2, the normal range is 35 to 45 milliliters of mercury. If you're under 35, you are hypocarbia. If you're above 45, we consider you hypercarbia. For bicarb, the normal range is 22 to 28. PCO2 is the partial pressure of CO2 in the arterial blood. The level is controlled by the respiratory system, and it tells you how well the patient is ventilating, whereas bicarb is the measurement of bicarb in the arterial blood, and it's regulated by the kidneys. Acid-base disturbances. Anything below 7.35 we consider acidotic, and if you're above 7.45 you're alkalotic. Alkalosis will lead to tissue hypoxia, cause vasoconstriction, and cause O2 to bind tighter to the hemoglobin. Respiratory alkalosis is hyperventilation, the stimulation of the respiratory center, and overventilation. Mechanical overventilation. Metabolic alkalosis can be caused by an accumulation of too much base, a loss of too much acid, and some common conditions associated with this are excessive gastric suctioning, severe vomiting of stomach contents only, potassium deficit, medications such as antacids or diuretics. Here's some awesome pictures just showing the signs and symptoms of respiratory and metabolic alkalosis. Acidosis. There's respiratory acidosis. All of the following causes I'm about to list involve hypoventilation for respiratory acidosis, including COPD, pneumonia, respiratory muscle wall weakness, mechanical underventilation, a barbiturate or sedative OD, near drowning, suffocation or choking, and chest wall abnormality, kyphosis or obesity. For metabolic acidosis, some causes are from accumulation of too much acid, a loss of too much base. It could be due to diabetic ketoacidosis, lactic acidosis, renal tubular acidosis, renal failure, severe diarrhea, starvation, or poisoning. Again, here's a great picture just demonstrating some signs and symptoms of acidosis. So be sure to look out for these. This is a flow chart just to piece together everything I've said thus far. If you're a visual learner like me, it's everything we've discussed, and it's just broken down into simple steps. It's great to reflect on when you're trying to break down the values to see if the patient is respiratory alkalotic, acidotic, or metabolic acidotic or alkalotic. This graph is another visual, again, to show you a patient's condition. If you just plug in their values to this chart, you will need to figure out if the patient is compensating, partially compensating, or uncompensated when you do apply all of this information in the PowerPoint to equations. These are my references, and thank you for listening. This concludes my super fast explanation of the regulation of acid-base balance. Hope it helps. Thank you for watching.